This is Brian Putt. Today I want to talk to you about IT risks. We're going to look at this through a case study. Yeah, I think everyone's probably familiar that IT risks have increased over time, and particularly with the Russian invasion of Ukraine. More and more hackers are out there wanting to get a hold of credit card information, your social security number, all your information, personal information. Businesses are at reasonable risk, and they're spending a lot of money to minimize those risks. So this is a little bit old, but I think it emphasizes the need that $1.7 trillion each year in the data losses and lost time. IT web is 2.1 trillion by 2019. I don't know what it is today. I couldn't find that number. But anyway, it's a big number. And so companies are working on it. So what can we do about it? Well, there are many types of risks. And the way you assess those risks is by looking at the frequency of the occurrence and the cost for the data losses. Let's say if we're talking about moderate data losses. So you're going to multiply these two things together. That requires assessing those uncertainties. But what does Sam Savage say from probabilitymanagement.org? It says decisions made with deterministic assessments are often wrong, as anticipated results are either too high or too low. So you go to your managers and you say, hey, what's got the most risk here? Or what can you do to minimize it? And they can pick up the easiest low-hanging fruit that they think they can say, well, we can work on this, and that'll reduce our risk. Well, that may be true, but is that a good use of the resources you have? You could have scenario planning, but I don't think scenario planning is any worth anything unless you've got probabilities assigned to those scenarios. So what we want to do is use the decision quality tools and simulation to properly assess these uncertainties, and then use that to make good decisions on where to spend our IT dollars to mitigate the risks. I'm going to be using SIP math here to evaluate this in a model. So what's necessary once I have these two assessments? I have the frequency that I've assessed, and let's assume we've assessed it as this sort of distribution. It could range from 0 times a year to this looks like about 13 times a year that something could happen. And then there's the cost. If I have an occurrence, what is the cost of that occurrence? And the way this would work is saying, I'm going to first sample from the frequency. So let's say I sampled 3. It happened 3 times this year. So then I have to sample from this cost 3 different times, and then add that all together to come up with a cost. That becomes one data point over here. And we repeat that a number of times, and eventually we have a full distribution here of the cost. So you can see here that the total cost is probably going up to about 14. But when we do this cross multiplication with the frequency, we're actually getting an expected value of 37 and an upside cost of possibly 90 to 100. So the SIP Math Modeler tool makes this simple. It's an easy calculation using their tools and SIP Math. So what is the difference between IIDs, which are independent, identically distributed variables, and assuming a single cost in the trial? So when they're the same cost is used for all events in the same trial, the uncertainty is higher. So if they're correlated, you get this blue line, okay? But when they're IIDs, you get the orange line here. And you can see that the risk is a lot less. That's the central limit theorem coming in. But also notice that the means are the same. So we want to use IIDs for this particular evaluation. So now let's look at something a little bit more elaborate. And we've got a model here that's got several different types of costs, IT losses. They've broken down the data losses into 3 categories: severe, moderate, and low. And then there's also operational risks. And I think there's also some system integration costs over here as well. In any case, I just want to focus on a few of these elements and show you how we can make a decision on how to spend our IT mitigation budget. So let's assume that we have three different types of data losses: severe, moderate, and minor. And the frequency is given by a Poisson distribution. I'm going to show you what that looks like here in a minute, I think. We've already seen one previously. But in the severe, that happens like every other year on average, half an occurrence per year. But remember, we're not going to actually end up with a half. It'll either be 0, 1, 2, 3, or 4, 5. And then in the moderate, it's 5 per year, and in the minor, it's 20. And you can see the costs here of resolving each one of these types of data losses. Obviously, the severe has a higher cost than the moderate, and the minor data losses are very small, but there's a lot of them. There's 50 of those. And then we have the operational downtime impact. This even has a higher frequency of 50 and even a lower cost here. But when we start multiplying this range of costs, but having 50 of them a year on average, the cost is much higher. This is showing the number occurrences of the operational downtime. You can see these little stair steps here. And in this simulation, it averaged to 50.03. We can also look at these costs and do a tornado chart. And so here we can see the cost of lost data moderate or lost data severe. And these points over here represent the P10 and the P90 of the cost distribution. So the number of records, which we haven't talked about, which was another operation, which is another cost, it has very little impact. And the cost per record has a very little impact. Cost of implementing domestic has a very little impact. So, and minor data losses has a minor impact, even though there are a lot more of those. So that was informative. The tornado chart is informative, but I think we get more information by looking at the cumulative distribution function. So here we've got, I didn't put a title here, but this is the number of occurrences, and this is the cumulative probability. So with the major severe occurrences, that's this line here. There's a 60% chance that we don't have any occurrences in a particular year. Remember, it was only half of an instance per year was on average. And then we have quite a few times we have 1, and then 2, 3, and 4. Or maybe this is 1, 2, and 3. 1, 2, and 3. So we can see that the moderate breaches has the largest contributor to the total cost. So the moderate is over here at 5.04 loss average, moderate. And the severe is only 0.48 is the number of occurrences. We have to get down here to the cost. Let's look at the cost. The moderate has 37. The severe only has 17. And if I add up all of these over the simulation, the total lost data is 78, which should be the sum of these three things here. So you can see they have very different shapes. And this vertical line here corresponds to this vertical line over here as well. So what we want to do is figure out which of these do we want to mitigate. So what are we going to do? Well, we have to come up with a scheme, and I'm not telling you how to mitigate those costs. That'll depend upon your particular company and how you can go about it, what you can brainstorm as far as things to do. And there may be many ways. I'm just going to show one here. So in this particular case, for the severe, we're going to reduce the frequency from 0.5 to 0.3. So we'll either use one or the other here, depending upon whether we're mitigating. And if we mitigate to the 0.3, then we incur the cost to improve the security, which is going to be 5, 7, or $10 million in a triangular distribution. We can also do the moderate data. And here we're going to change the cost of the moderate data. So the base case was 2, 5, and 15. And if I mitigate the cost of recovery, if you will, it would be 2, 3, and 10. So once again, I can decide what, if I'm mitigating, I'm going to use this lower line rather than the upper line. And the cost to mitigate that moderate data is shown here. Now for the operational downtime, we can reduce the number of cases from 50 to 25. And we can also reduce the cost of the downtimes. Here it didn't change the minimum and the most likely, but it did change the maximum. And then we have a cost to implement. But now also notice we put in here a probability of success. If I implemented this and incurred this cost, what's the chance that I'd actually achieve this reduction in the number of incidences? So you can incorporate that aspect into your analysis as well. Now, one of the features of SIPMath with the enterprise version, which costs $500, but you don't have to use that. You can replicate this using a little bit of VB, I believe. Well, I know you can. So put together a strategy table and then evaluate all of those strategies at one time using SIPMath, even the free version with a little bit of VB. So what I've done here is I've defined every possible strategy, which was no mitigation, just mitigating severe, mitigating moderate, mitigating operational, mitigating the severe and moderate, severe and operational, moderate and operational, and doing everything. These were just extra ones I put in here so I could add some other things easily to the model. So I have 8 different strategies here, and I've calculated the total cost and then also the mitigation costs. So what do these strategies look like? Well, I'm going to show you 4 of them. One is the no mitigation, which is the gray line here. And then we have over here on the left is the moderate plus operational. And you can see that in this particular case, we're trying to mitigate this. So we're trying to be over here. This is better over here. So it has a total cost of 143 versus the no mitigation of 160. Well, maybe you say those don't look very different, but why don't we go look at the high cost side of it? So what I've done is blown this side up to show you this graphic. And we can see that there's a 20% chance with the moderate plus operational that our costs are above, I'll call it 165. Whereas with the no mitigation, there's a 20% chance there's above, call it 190. So this becomes very subjective, whether you want to reduce that risk on this upside, this high cost side. But this is one way to look at it. Now, another way to look at it is through something similar to a capital efficiency chart. So I plotted here the mitigation costs versus the total cost, including mitigation. And so these data points here come directly from this strategy table, And then I establish a criteria. It was my criteria. Your criteria might be different. But I said, for every dollar I invest in mitigation costs, even including the mitigation costs, I need to reduce my total risk by a half. So this is total cost savings divided by the mitigation costs. Now drawn a line through here. This is 60, 0. And if I increase this by 20, this has gone up by 10. So things that are above the line are good. So what we see here is that the one that's the best actually is just the operational or moderate mitigation. That is the best option. Although moderate plus operational is a close second. Just operational could be done, but it's not as good as these other two. So this is a good chart to use to make a decision of how to spend your IT mitigation budget. Hope you found this video of interest. You can visit probabilitymanagement.org to learn more about SIP math, read the flaw of averages. I think there's a new version of the flaw of averages out now. And review the many videos on my YouTube channel, of which you're watching one of them now. It covers a wide range of topics here. If you're interested in getting a copy of the model, I'd be happy to send it to you. Just send me an email to brian@theputz.com. Thank you.